So we learned about inheritance last time. Alright, and we looked at this example. Now in this example I forgot to show you the test class. So again, just to remember, we have the superclass, geometric object, and then we have two subclasses, circle and rectangle. And since circle inherits everything, both circle and rectangle inherit everything from geometric object. This means what? That all of these methods can be accessed, can be called using an object of the type circle. The same goes for rectangle. All of these methods can be called using an object of the type. It's basically as if these methods are in the same class with us. The same goes for the data fields, but of course the data fields are private, so we can only access them via their methods. Right, let's look at the test class. There we go. So this is the test class. And let me just open the superclass again. So this is the superclass. Type. Okay, so again, a very simple example. I just created an object of the type circle from simple series geometric object. The radius here is 1. Right, then circle dot toString. You see this method? What was this method defined? And the superclass. Very good, very good. If you look here, this is superclass. See, this is the toString method. Here you see, I can call with the object from the subclass. Alright. Type circles.getColor. Again, this is a method in the superclass. Get radius in the subclass. Get area in the subclass. Get diameter in the subclass. Then I have rectangle. Rectangle from simple geometric object. Again, rectangle.toString. This method is in the superclass. Get area is in the subclass, and then get perimeter is in the subclass. Yes?
.toString can be built in Java?
No, it's not built in. It's not built in. You will understand where this comes, inshallah, later on, when we learn about the toString and the equals method. And then you will see why almost every class has the toString method. Okay? It's basically an abstract method in the object class, the parent of all classes. But don't worry about it. But is it built in? No, it's not built in. Type. So this was inheritance. Very well. And then we learned about constructors, and this was very important. We learned about constructors, and we learned about constructor chaining. And what is the rule here? What happens when I create an object of any Java class? What is the rule? We go to the constructor, then what? What happens? Raise your hands. Yes, fine.
Constructor of the superclass. Constructor of the superclass.
على طول اروح للconstructor of the superclass.
This.
What is it?
This.
This? What are you talking about?
The constructor of this.
That's not what we learned, no. You are kind of jumping around the idea. So what happens when you create an object of a subclass? What happens? What is constructor chaining? Yeah, the subclass extends the superclass. What happens when you create an object of it? I go to the constructor, then what? What do I check? I check one of 3 scenarios. Remember last time? What was it? What were these scenarios? So what happens to the constructor of the superclass when I create an object of the subclass? Do they get called or they never get called?
They get called.
They always get called. So what were the 3 different scenarios? When you create an object of a subclass, you go to the constructor of that class. Then you check. Did you call another constructor in the same class? Or did you using this? Or did you call a constructor of a superclass? If you didn't do any of these, Java will call the constructor of the superclass with no arguments. Remember that? And this goes on up the chain. All of the constructors of the superclasses will be called eventually. Type. Alright, and then we looked at what happens, an example of what happens if a superclass does not have a constructor with no arguments. Very good. Now, a subclass, again, inherits from a superclass. Of course, other than the stuff that you get from the superclass, you can also add new properties, new data fields in the subclass, you can add new methods, and you can also override the methods of the superclass. Override is not the same as overload. You will understand the difference. Like, for example, the print circle method. Print circle was in the circle class. Okay? We can do something like this. System without the printer, the circle is created plus super dot get date created. What is super dot get date created? There you go.
Just get water.
Super dot get date created. What is super dot get date created? The get date created method from the superclass. Now, by the way, do we really need to use super here?
No.
Now, why? Because there's only one get date created method in the superclass. I don't really need to say super. It's inherited anyway. So I can say get date created straight away. Or I can use the keyword super. The same thing. Plus, and the radius is radius, which is the data field inside the superclass. Type. Overriding methods now. What does overriding mean? Having a method in a superclass, and then having the same method with the same header. I'm not talking about the implementation. I'm talking about the header of the method. The exact same header of the method in the subclass. And the exact same name, the exact same arguments as well. Overloading was what? Having more than one method with the same name, but they receive different arguments. This is overloading. Overriding, no. Overriding means having the exact same header, the exact same name, the exact same arguments. We can do this in a subclass. Of course, we cannot override a method in one class. Of course, we cannot have the same exact header for two methods here. We cannot do that in the same class. But we can do it in a subclass. And what does this mean? So a subclass inherits methods from a superclass. Sometimes it is necessary for the subclass to modify the implementation of a method. Most of the time we modify the toString method. Equals method. We'll learn about equals later on. Type. So it is necessary for the subclass to modify the implementation of a method defined in the superclass. What do we call this? Method overriding. So, inside the geometric object class, we had a toString method. And this is the header of it inside the superclass. Public string, toString, and no arguments. I can redefine the method in the subclass. What do we call this? Overriding. Very good. So here we go. Inside circle, I say public string, toString. Okay? Like, look how I did it here. Instead of repeating the code from the superclass, I can say something like return super.toString. Which toString method is this? The one, very good. The one in the superclass. Here it is necessary to use either super or this to differentiate between the superclass and then the class that we are currently in. So super.toString, we mean the toString method in the superclass. Plus radius is radius. Type. If I go back to the superclass, this is the superclass. Let's go to the toString method. Here it is. Public string toString. Again, the exact same header. Return. See, this returns a string. What does the string have? Created on. We have the date created field, the color, and then filled. Circle inherits everything from geometric object. What does circle have in addition to these? The radius. So I only need the radius. Only the radius is left. So instead of rewriting the code to get the values of all of these fields, خلاص, use the toString method in the superclass, then add to it. Where did it go? There it is. Then add to it whatever string you need or whatever value of data fields you need from the subclass. You see here, super.toString will return a string having the date created, the color, and whether it's filled or not. Add to that string, there it is. You see how now I don't need to, I'm not rewriting the code. No, I use the code from the superclass. I use the method from there. Type, and this is very example. When I create an object of the type circle, and I say this, let's just say name it circle 1, for example. And then I say circle 1 dot toString. Which toString method is going to be called? Very good, in the subclass. The subclass. If I create an object of this class, of this type, circle, and then I say circle dot toString, which toString method is going to be called? This one, not the one in the superclass. Because again, the method has been overridden, Type. Now, let's learn some rules about overriding. An instance methods can be overridden only if it is accessible. Yani, can I override a private method? We know that anything that is private, I cannot really access it. Thus, a private method cannot be overridden because it is not accessible outside its own class. If a method defined in a subclass is private in its superclass, these two methods are completely unrelated. So let's just say مثلا toString method in the superclass is private. That doesn't make sense, by the way. Why are we making it private? But let's assume that it is private, and then I redefine it in the subclass. Do they have anything to do with each other? No. So this is not really overriding. But of course you can do it. Since no issues of doing it, but we don't call that overriding. What about static methods? Can we override static methods? So like an instance method, a static method can be also inherited. So again, subclass inherits everything, except for the constructors. However, a static method cannot be overridden. So what if I did that? What if I redefined a static method in the subclass, the exact same header and everything? If a static method defined in the superclass is redefined in a subclass, the method defined in the superclass now is hidden. So if you redefine a static method in the subclass, you have no access to the one in the superclass anymore. You see what's happening here? So with static methods, if you redefine a static method in the subclass, you will have no access to the one in the superclass anymore. That's why we say that we cannot override the static method. Because again, the concept of override is redefining the method and still having access to the one in the superclass. This is what override means. Yes, I redefined it here, but I still have access to the other one in the superclass using the super keyword. Here, if I do it with a static method, khalas, the static method blocks the one from the superclass. You cannot access it anymore. Questions so far? Questions? Right, let's look at this example. Overriding versus overloading. Right. Alright, before we go to main, okay, so I have class B, and then I have class A extends B. So B is the superclass, A is the subclass. Okay? Yani A inherits everything from B. Good. Now B has a method, public void, the name of the method is B. It receives a double. What does it do? It prints whatever it receives times 2. Very simple. A now. A, we have public void B dot C. This is what? Is this overload and override? What is this? Yes? Override, yeah. See? The exact same arguments, the exact same name, the exact same header. This is override. Type. What does this one do? System. This one only prints the value. So this one prints the value times 2. This one prints the value. Okay. Let's now go to main. I create an object of which type? A. Type. If I say A dot P and then I pass 10 to it, which P method is going to be called? The first one or the second one? Huh? The second one. This is of the type A. The method has been overridden. So this one is going to be called. So what is the output here? 10. Very good. 10. Type A dot P 10 again. Huh? This is 10 int and this is 10 double. Both of them will call the method in the subclass. Again, because the method was overridden. Now look at overload now. Again, the same thing. I have class B, class A. A extends B. So B is the superclass. A is the subclass. In B, I have public void P receives a double. Again, it prints the value times 2. In A, public void P receives is int. This is override or overload? Overload. This is overload. Having more than one method with the same name but with different arguments. And we can do that in the same class. And of course, we can do it also in the superclass and subclass case. Like, what does this one do? This one only prints the value. Like, okay, let's go now to main. I create an object of which class? The subclass. Okay. A.p and pass an int. Which one is going to be called? The one in the subclass or the one in the superclass? And the one in the subclass. Very good. Type. Meaning it will print what? 10. A.p, then pass 10.0. What is 10.0? Double. Which method is going to be called? Very good. The one in the superclass. Very good. Because this is method overloading, not overriding. Meaning, with the same object, I can call this one or this one. No problem. But here, overriding, you can think of overriding as if I have, redefining them. It's like the method has been overwritten. Okay, you can think of overriding that way. Questions? Questions about overriding and overloading? Any questions? We use overriding a lot. Because when you inherit everything from a superclass, a lot of the time you inherit methods that are either that don't make sense sometimes for your object, or so what do you need to do? You need to just modify them. How do you modify them? Override them. A lot of the time this happens. But now, the object class and its methods. Object class and its methods. The object class is, let's just say, the grandfather of every class in Java. Every class in Java extends the object class. Every class in Java is descended from the object class. Where is the object class? It's in the Java.lang package. Remember when I told you anything in the Java.lang you don't need to import? Remember that? If no inheritance is specified, when a class is defined, the superclass of that class is what? Is object. So if I have a class, and I don't say this class extends wherever, so there's no inheritance here. By default, it inherits from where? From object. Very good, very good. Yani at the end of the day, if you look at a chain, any chain of inheritance in Java classes, who's at the top? The object class. Very good, the object class. And then, like the example from person, employee, and faculty. Remember that? Person, employee, faculty. So employee extends person, and then faculty extends employee. So what about person? Very good. Person extends object. Here you go. Here you go. So, if I say public class circle, or public class extends object, it's the same thing. It's the same thing. Alright. Now, the toString method. Where does the toString, and this is an answer to your question, where does the toString method come from? The toString method returns a string representation of the object. This is the purpose of the toString method. The default implementation, where is the default implementation? Where is it? It's in the object class. Remember, again, the object is the grandfather of all classes. So, if you go and open the object class, you will find the default implementation of the toString method. So the default implementation returns a string consisting of a class name of which the object is an instance. Yeah, if I do not override the toString method in my class, if I just create a simple class, create an object from it, there is no toString in there, huh? There's no toString. And then, like loan, for example, loan, new loan. Inside the loan class, I don't have toString. But then I say something like this: system.out.println loan dot toString. Where is this toString method? In the object class. Very good. It's in the object class. What is the default implementation of it in the object class? It returns a string consisting of a class name of which the object is an instance. And then at, and then a number representing this object. Yeah, if I do something like this, the code displays something like load at this number. This message, of course, is not very helpful or informative. Usually, you should override the toString method so that it returns a digestible string representation of the object. By the way, most of the time, this number is basically the memory location of where this object is stored. Okay? This number is basically the memory location of where this object is stored. This is the default implementation of toString. That's why it is best practice that you override the toString method. In any class, you are going to create objects from later on. Best practice. Always override the toString method. That's why you see almost all of the classes in the Java library have the toString method. All of them have the same header. Override, not overload, override. Public, string, it returns a string. The name is toString like that, and it doesn't receive any arguments. You override it. What do you put inside it? A string that actually represents your object. If you create a class student, for example, you can have a string there showing the name of the student, maybe their ID, their major, etc. Anything that has information about this object. Questions about the toString method? Questions? Very good. But let's have just a 3-minute break. Okay. Inside the classroom. Huh? You can just